Hi, yeah, this is Mike Gilson, and I wanted to give you an update on some of the directions we see for D3R and also to request input from you on a number of aspects. I want to talk about the status of our collection of data sets, which is largely thanks to a number of folks in the pharmacy industry, and then about how the available data sets map into what we want to do with grand challenges over the next couple of years. This is a chance again to get your input and to clue you into what's coming down the pike so you can be prepared. I then want to spend a little bit of time on something that Peter mentioned, continuous evaluation of ligand protein predictions, or KELP, which I think is actually gathering to be quite a cool and useful exercise. And then I'll say a little bit about our thoughts on a forthcoming in-person D3R workshop in February of 2018. So in terms of data sets, we're really happy that we have quite a number of data sets that are already on hand and ready to be rolled out in new challenges. This is a partial list. This is in some ways probably the leading list, but there are other components as well that I don't list here, and there are others which seem to be on deck in industry. I want to take you through some of the highlights here. There are three what I'm calling bespoke, because we basically commissioned these D3R kinase data sets with measurements of KD. There are some interesting subsets here because we were able to design them. There are 100 varied compounds for which KDs have been measured against 3 different kinases, so we can get a look at specificity as well as affinity rankings. We also looked at sets of congeneric compounds against one kinase where there are activity cliffs that needed to be accounted for. So there may be some interesting puzzles to look at. And then a smaller set of still one compound against a wild type and 6 mutants of one kinase. So maybe a bit of a small set, but sort of interesting to look at variations in the protein as well as the ligand. There are 2 more sets that are rather similar to Grand Challenge 2015 and Grand Challenge 2 in the sense of having a set of crystal structures and on the order of 100 to 200 IC50s, which are listed next, FEP, ACE, and base 1. And then there's some sets that are in some ways special interest. There's a cathepsin S set from Janssen, which has an enormous number of affinity data and may be of interest to cathepsin gurus because these are non-covalent binders as opposed to covalent. There's a set that's essentially a follow-on to a CSAR data set of LPXC, so this is another chance to have a go at this enzyme, which is complicated by having a zinc. And then there's a set of fragment-bound crystal structures which we think are going to be forthcoming from the Fraser lab. And then there's some additional ones that I won't go into. So with these available, what we're contemplating is a roadmap of about 2 challenges per year with a minimum of 1 protein target per challenge, maybe 1 primary case and 1 secondary, with formats similar to what we've seen, and we appreciate your input on whether that's a good way to go. And so that would be a challenge coming up this year, 2 more next year, and 1 to 2 in 2019. A couple of enhancements we're contemplating. One is to address the issue that results of docking tend to be controlled a lot by what protein you're docking into. So we may put in a stage 1B where we'd release the co-crystal structures but without the ligands. So you now would have a self-docking challenge, which would test the algorithms as opposed to your ability to pick the right protein structure. And another one is that given, it would be interesting now with absolute binding free energy methods coming online, as opposed to relative binding free energy methods, to look at more varied chemotype sets for the free energies. And that may let us put them on a more of an even footing of comparison with the scoring methods. I want to talk about KELP. This is based on the weekly release of new protein ligand crystal structures from PDB. Every Saturday they release forthcoming PDB IDs, the protein sequences, and the INCHI strings or SMILE strings that go with those. And on Tuesday they release the actual structures. And what that means is that there's some time in there where we can identify cases where there is a similar, essentially a matching protein in the PDB. For each resulting target that then has a match in the PDB, we can give you up to 5 candidate structures to dock into. For those who don't want to do preparation, we can prepare the structures and the ligands for docking and push these data packages out for your use. You would then run the pose predictions and push the data back at us. This is on a fairly quick time scale, so we're looking to people to develop automated servers. Tuesday, the PDB releases the actual structures, and we can do basically RMSD calculations against those. And the goal ultimately is to have a web page with running summaries of how various methods are doing as the data accumulates. And we find that there are on the order of 50 suitable co-crystal structures a week. So this is going to generate a pretty nice data flow. So this happens week after week. Maybe I'll skip this. No, okay, we'll just go quickly. So this is the kelp week on Sunday. Basically, we get access to the ligand inches and the proteins and send the information out to you. We accept submissions the rest of the day, and on Monday, data have to come in. Your predictions have to come in on Tuesday, 3 p.m. Pacific time. We do the evaluation. Then there's a little breathing room, and then it all starts over again. The structures that we push out to you to dock into, just to avoid your having to do all this, you're allowed to use your own protein structure to dock into, I should say that, but we also push out several options, the highest resolution APO structure, as well as several ligand-bound co-crystal structures based on degree of similarity or dissimilarity with the challenge ligand. So the status right now is there are 4 participating groups signed up to date, actually several participants from one of the groups. There are 2 academic labs, 2 software companies, and we think this is pretty exciting and invite you to sign up as well. We're going to work with you to get this up and running, so you don't have to have it all ready to go right off the bat. We've developed, and this is really Jeff Wagner working with Chris Churis and others here, a software called KelpAid, which is something you can download and install that helps orchestrate receiving the data packages, calling your pose prediction tool and uploading the predictions, and it's available on GitHub, and there's even a video, so you can watch that. Another direction, and a direction we're really interested in going, this is a little more blue sky, but is something that we're tentatively calling Kelp Plus. So what Kelp does is challenge you to predict poses. Ultimately, we want to be able to get affinity predictions here too, and the challenge there is to do that on a blinded, rolling basis. Now, affinities are always being published week after week by journals like JMed Chem. How do we turn those into blinded challenges? What occurred to us is maybe the best way is if folks put together really black box canned workflows that we can toss in the identity of the protein and the identity of the ligands, such as in Docker or Singularity containers, and crank through the results. So if those packages are sitting and running on our cluster, for example, they become blinded predictions. And so we'd be able to also do rolling evaluation of affinity prediction technologies. And so this is something we'd love to talk with interested folks about. To learn more about Kelp, several of us are going to be at the forthcoming ACS National Meeting. There's a poster from Jeff and the comp poster session. Shwai is going to give a seminar as well on Wednesday. And there'll be several of us floating around the comp poster session in addition to Jeff. There's information on the web, on our website. There's a Google group if you're interested in chit-chatting, and there's a wiki. There's a GitHub with a wiki. And in general, feel free to contact us directly as well. Finally, so in 2016, we had an in-person workshop here at UCSD. There were around 85 participants. It seemed to be very productive and positive. 2017, we're here today in this webinar. 2018, we thought it would be important to go back to an in-person workshop and get a little more intensive interactions going. So we're tentatively penciling this in for February 21st, 22nd, again here at UC San Diego. So it'll be warm during those winter months. And this time we might hold it on the Scripps Institution of Oceanography campus because it's walking distance to the hotel, so you can hang out on the beach in between sessions. Hopefully, again, this would be joint with Sample. There is an expression of interest in that today, and we're working with other folks to try to put that together. And we're also contemplating an optional third day, which would be, in a sense, extracurricular outside of the regular D3R effort for practical training in some of the methods that may have worked particularly well. And in general, we would invite your suggestions for format and content of the workshop. So that's it for me. I'd be happy, I guess we have a Q&A now, is that right? Which could encompass Peter's comments as well as mine.